Right, welcome to part 4 of lecture 2 for FMGT3224. We just finished doing basic exercise 8-2 or brief exercise 8-2. We're now going to look at how cost volume profit relationships look when we graph them. So looking at our wind bicycle example here again, different levels of output here. So in this particular case, we're looking at 300, 400, and 500. And really it's the whole relationship there. So if we are to graph them now, let's think about how this actually looks. We've got the sales in red, right? So sell 0 items, have 0 revenue. Every time you sell one more item, you get a bit more revenue and so on. So it's going to start at 0 and move up like this. The cost function, there's an element of fixed cost and an element of variable cost associated with the bicycles. So the fixed cost piece is as shown on the graph here, and then the variable cost is just driven by the slope of the line. And as we approach, remember we did the calculation previously that showed the break-even point was 400 units of production. Well, as we approach that point, you'll see then that the total expense line crosses the revenue line, and that would make sense graphically because that would mean that the revenue is equal to expenses, and therefore net income is 0. So we're essentially breaking even right at that point. So anything to the left of that, in terms of quantity produced and sold, you're in a loss. In other words, your expenses are higher than the revenue, so you're going to lose money. And anything to the right of that, your revenue is going to be higher than your expenses, and therefore the amount here, the difference between those two at any given level of production, is the actual amount of profit that you're going to get. And we can represent that like so, right? So this this area here is actually the profit, and this is the loss. Okay, so obviously this is going to have several underlying assumptions. One is that the selling price itself is going to be constant at every level of volume. So there's no volume discounts that we're playing with here. Big one, costs are linear within the relevant range that we're looking at. And of course that we can divide them into fixed and variable. We're not going to do multi-product cost volume profit, but if we did, the sales mix would have to remain constant. In other words, if you sold 2 of one and 1 of the other, that no matter what level of volume, you'd always have to sell double of one product than of the other. Anyway, we're not going to worry about that because we're not going to do multi-product cost volume profit. And because we're looking at costs, there's cost of production as well as so period and product costs. Here we're saying, look, the costs that you incur in a month are basically constant. So whatever you produce is what you sell, and that again, these are all assumptions that are largely unrealistic in the real world. The whole purpose of this is to give you an understanding of how these costs behave as we change the volume of production. So what impacts profit, how profit behaves as you increase or decrease sales, and so on. Okay, so we've got some data here again. Win is currently selling 500 bikes per month. Company thinks that if they spend $10,000 in advertising, that will increase bike sales to 540 units. Should we go ahead and do this? Well, so as we look at this then, even though we're selling more bikes here, because our fixed costs have gone up, our profit actually ends up going down a little bit, right? So these are some of the kinds of scenarios you can play with using cost volume profit analysis. And And so the shorter way or quicker way of doing that, of solving the particular problem, is to say, look, the contribution margin for the incremental 40 units, $200 times the 40 gives you the 8,000. That's how much you're going up in revenue, but it's not enough to cover the increase in cost, and therefore you're going to lose money. So you can save a bit of time just playing around with the contribution margin. Now, there's two ways of doing this. Either one of these is acceptable, either the equation method or the contribution margin method. The equation method, and if you're good mathematically and you're more comfortable just doing this, then that's fine. You can turn your, when you're looking at a break-even point, basically, profit becomes zero, so sales has to equal your expenses, and as a consequence, it's just a matter of doing a bit of math, solving for Q, and that gives you the quantity at which you break even, which we've already sort of proved at 400 bikes. But using cost volume profit and the contribution margin method, we can do this very quickly, as long as you remember the formula, by saying, look, it's fixed costs divided by the contribution margin per unit, okay? And that will give you the number of units for the break-even point. You can also use the contribution margin ratio to get the total sales dollars. Just personal preference, I like that one a little bit. To me, it's a little bit simpler to remember, but whatever works for you. So we're now going to do brief exercise 8-4 to try and solidify some of these concepts. All right, so we are on page 357. Moro Products has a single product, a woven basket whose selling price is $54. Variable cost is $45 per unit. Monthly fixed cost $25,200. Required number 1, complete the company's break-even point in unit sales using the equation method. Now, as I mentioned, the equation method is really just a bit of math, and I'm not going to waste time doing that. I will simply show you the answer here, and you can solve the equation on your own if this is the way that you like to operate. Requirement number 2, break-even point sales dollars using the equation method and the contribution margin ratio. Okay, same deal. Again, solving for X, fair enough. Okay, now moving on to requirement number 3. Compute the company's break-even point in unit sales using the contribution margin method. And that is fixed cost divided by contribution margin per unit. And we said fixed costs were $25,200. Fixed cost per unit was, well, let's see, contribution margin per unit. Selling price 54, variable cost 45 gives us a contribution margin of 9, right? So selling price 54, variable cost 45, contribution margin of 9, okay? So 25,200 divided by 9 gives us a break even of 2,800 baskets. And that should jive with what we calculated up here. Okay, number 4. Compute the company's break-even point in sales dollars using the contribution margin method and the contribution margin ratio. Okay, so this is going to be fixed cost divided by contribution margin ratio. And we said fixed cost was 25,200. Contribution margin ratio was the contribution margin divided by sales, or selling price in this case, and it is 1.0.1666 repeater. Okay, so 25,200 divided by 0.1666 and so on gives us a $151,200 as the answer. So at sales of 151,200, we break even. And that should jive with, okay, well, they're rounding here, so that should actually be 200, and that's why. So anyway, close enough. And that concludes the exercise. Okay, so that's nice, break even and all that kind of stuff, but who goes into business just to break even, right? We all want to make money at this game. So rather than just look at the level of sales or activity at which we break even, we can actually expand this and look at and do something called target profit analysis. And basically, it allows us to answer the question of how many bikes do we have to sell to earn a profit of $100,000. And we can use the equation method. Again, we'd solve and get a quantity of 900, or we can use a contribution margin approach, and that's simply a minor modification. And if you think about it, the profit that we want, if we pretend that profit is a fixed cost, then we add that profit to the fixed cost, redo the break-even calculation, and then at that whatever level of output or productivity it tells us, we will have not just our normal fixed cost, but this additional amount that we will have covered with the contribution margin of everything sold, and that will be the target profit. So in this particular case here, fixed cost of 80,000, target profit of 100, so 180 divided by $200 per unit means we have to sell 900 bikes to reach that target profit of $100,000. Now, what happens when we introduce income tax to all of this? Well, I mean, the answer is you convert, if you're looking for an after-tax target profit, you convert it into its pre-tax amount, and then do your calculation based on that. So the pre-tax amount is simply the after-tax amount that this is the number that you want to figure out in your calculation, or you're basing your calculation on arriving at this number. But you then have to divide that by 1 minus the tax rate. So it will become a larger number as a pre-tax amount. And then you do your calculations based on that. And we'll take a look at this in the brief exercise 8-7, page 358. We're only going to do the contribution margin format requirement, not the equation method. So requirement 2 only. Okay, so using the data from problem 8 or brief exercise 8-6, but add in a 40% tax rate, we need to do requirement number 2, which basically says use a contribution margin approach, compute the dollar sales required to earn a target before tax profit. I think they mean a target. Now we're talking about an after-tax profit here. So an after-tax profit of 15,000. Okay, so I think we're going to continue this in part 5 of the lecture.